Number 48. Whoops. There we go. Number 48. Which acid, A or B, is stronger in each part? So you're given 3 clues, and they should each tell you whether A or B is stronger. So the first one says B dissociates to a greater extent in water. Well, that tells us that B would be the stronger acid and A would be the weaker acid. So when you have an acid that dissolves in water, the stronger it is, the more of those acid molecules become dissociated. So if it's a 100% strong acid, then 100% of the molecules would dissociate. Okay, so the more that dissociate, that means the larger the percent of them release protons, the stronger the acid of it is. So B is stronger than A. The next one is, the next clue is A has a larger Ka. Well, that tells us that A is a stronger acid. The Ka, the equilibrium constant, kind of tells us, it tells us how strong the acid is. Now, if it has a Ka, then it's a weak acid, but weak acids range in their strength. The larger the Ka, the larger the percentage of the acid molecules that dissociate. So Ka is a measure of the fraction of acid molecules that do dissociate in the water. So the larger the Ka, the higher that fraction is. And so this time A is a stronger acid, and B with the smaller Ka would be the weaker acid. Part C, the conjugate base of B is stronger than the conjugate base of A. This one's more tricky. When an acid molecule dissociates, that means it releases its proton. So let's imagine this taking part. So suppose we're looking at B, and here is what B looks like. So here's acid B. So there's the proton and whatever the proton is connected to. When B acts as an acid, what happens is that proton becomes detached. It becomes detached. And this is the conjugate base of that acid. Now, if this is a strong conjugate base, then that means it wants to grab that proton back. It doesn't want to let go of the proton. It wants to grab it back. Strong bases tend to grab onto protons. So if you have an acid whose conjugate base is strong, then that means it wants to grab that proton back. It wants to be like this. So that makes it a pretty weak acid. If it doesn't want to let go of its proton because its conjugate base is too strong, then that makes this a weak acid. Okay, now if B has a stronger conjugate base, then it would be the weaker acid. Okay, A would have the weaker conjugate base. That means A would rather be dissociated more than B would. So A would be the stronger acid. Hopefully that makes sense.